Hey, how are you? My name's Christopher Pies, and I like to think of myself as an experienced C++ developer. Today, I want to go over using a Docker container as a development environment, and this will be a second video in my series of videos on improving your C++ development pipeline. We're going to go get a Docker file. We're going to make an image out of it. We're going to make a container out of that image. Then we will compile a C++ program inside the container. And finally, we'll set up an IDE to develop using that container. So the first thing we got to do, of course, is go get Docker. I'm going to use Docker for desktop. I'm on a Windows machine. You might be on a different operating system. You might get a different version of Docker. Their website may have changed. I can't make any guarantees about what it's going to look like in the future. I've already downloaded and installed this, so it's fairly simple. I don't think I need to do that in front of you, but you could just do Docker for desktop in Google or go to the address here, www.docker.com. They got a nice little download button. I downloaded for Windows, installed it, and then started it up. And this is what it looks like. This is Docker for desktop, the Windows version. Might look different in the future. So let's get the version number for you so you can compare. I'm on 4.2.9 at the time of this recording. As you can see, there's already some missed updates. Close that out. When you install it, it's going to have over in the left pane the containers, images, volumes. All of these should be empty if you have a fresh install. I've got my dev environment already made here, and I've got an image for it already made and a volume already made because I did the walkthrough that I'm recording ahead of time, make sure everything works. So let's explain what some of these items are. We start with the Dockerfile. The Dockerfile is a set of instructions that tells Docker how to build the image. It might specify an operating system, maybe some software to install, configuration, maybe you copy some files over. The Dockerfile is what you could share with other people, and they could create an image and then make containers from that. The image is much like an image from a backup system. It's the starting point, the template from which you begin. It's got the state of things, the software installed. You go and create that image, and then in turn you create containers from it. The container is, think of it like an instance. It is an instance of the image, and it will carry any changes that you make forward, whereas the image is just that beginning snapshot from what you start. So you interact in your day-to-day with the actual container. And as you make changes to the container, those persist. Now that we've got Docker for desktop installed and we understand what images are and containers are and how the volume works, the next step would be let's create an image from a Docker file. I've made a GitHub repo that you can use. You can go and clone it onto your host machine, not a container. And we're going to use the Docker file in this repo to create an image and then create a container from it. If you'd like to make your own, you could use this as a reference if you like. I've got the address up here in the address bar. You could just Google Christopher Pies GitHub and find my GitHub repo. Not much in here. Get, ignore, license, readme, standard stuff. The only thing of interest really is this Docker file. So once you clone this, open it up, and it should look very similar to what's in here. I will go over the individual lines and what they're doing in this file. Let me make it a little bit bigger. I did make an assumption that you've got Git installed and you know how to use it and you were able to clone the repo. Okay. If not, maybe I'll do a video on that in the future. I'm not sure. I will, however, go to my host machine, the directory where I have my Git workspace, and I've pulled this. I'm going to open a terminal. I am going to make sure that it's up to date. Do a git status, do a git pull, and everything is indeed up to date. Now that we've got the latest version of the Docker file, let's go through it. I put some comments at the top. I like to comment most everything. Make a README for the repo, put comments in the Docker file. This is not only for other people, but it's useful for me. I've come back to this file after months go by and I don't remember, oh, how did I go and create the image, or how did I attach to it, etc. So I've written comments here that explain the different Docker commands. So to build the Docker image, the command is right there. And then to build the container, and then when we want to actually attach to the container and use it, and we're going to do these steps, so don't mean to hurry through those, but I want to right now go over the instructions in the Dockerfile. So the Docker files, they could be based on another Docker image. Here I'm going to use Ubuntu version 22.04 just for the operating system. So there is already a Docker with Ubuntu 22.04 in the central Docker repository. So I just say from that image, we're creating this one. I'm specifying that I like bin bash, that I'm the maintainer, and here I've given it a description. These are just some arguments that we're going to use in the Docker file. So I've specified a username, a user UID, and a user GID, and I'm going to use this to actually make a user named developer. This is the common stuff that you'll find in Docker files. What software are you installing? What software is this image going to have? And this is the meat and potatoes of what we're trying to accomplish. So here we're just doing an update. We're based on Ubuntu. So we're using apt, and we're going to run apt update. We're going to tell it answer yes to everything, because normally you put apt update or apt installed commands on the command line, and it'll prompt you yes or no for the dependencies. We're going to automatically say no to the recommends. And the things that we are going to install, I wonder, got extra spaces here. This should all be lined up. Sorry, maybe I'll fix that. So we're going to install sudo bash vim get ssh build essential. This is where all your development for C++ stuff is. clang, cmake, ninja build. Don't worry if you're not familiar with what all these things are. These are the very minimal essentials to go and do some C++. GDB, the debugger. I'm going to install wget, Python 3, and Python 3 tongue twister, Python 3 pip, which is the package manager for Python. And here I'm installing Conan, which is a package manager for C++, and that will go and grab dependencies for me and greatly simplify my life. I will do probably more than one separate video on Conan and why Conan is wonderful and everyone should use it. Let's see, in here, I am making that developer user. So here's where we're using those variables that specified earlier. And this is going to create a user named developer. Is going to give them permissions to sudo. Then we are going to be that user. And as that user, I'm going to create a directory. And I do that because I'm making a directory for the volume that we're mounting in the user's home directory. And that's all that's to it. So installing this software, installing Conan. Notice I do that separately because this is from pip. This is from apt. I'm making a user, becoming that user, and then creating a directory where I'm going to mount the volume. All right, so I can walk through this with you. I'm going to go ahead and delete what I have. And this would be a good time for me to mention that anytime you need to delete your image, you've also got to delete any containers made from it, and you have to do that first. So I'm going to go to the Containers tab here, shut this down so it's not running anymore. Then once it's exited, delete the container, delete it forever. And then I've got the image over here. Delete that forever as well. I'm not going to delete the volume. I want to keep any files that I had been working on. So I'm just going to leave that alone. Next, I'm going to go into the directory that has my Docker file. So here's that repo that we pulled, the dev environment CPP. Go into the directory that has the Docker file. I'm going to open a terminal in there, and then I will open the Docker file itself. And as I had mentioned earlier, I've got the commands in the Dockerfile. So this first one is going to build the image that is what we're going to make the container from. So there's the build command, and then I'm just going to name it dev environment cpp ubuntu 01. So we'll go to the terminal, plug that in. It'll start building. This could take a little bit depending on what's being installed, because it's running those commands. So however long it takes to run all those commands in the Dockerfile, that first run is going to take that long, pull down all that software, start installing it. So I'm going to go ahead and cut this bit out the video because I don't think you want to just sit here while this is building. If everything worked without any errors, you'll see down at the bottom that it completed. It's telling you what's next here. So what's next for us is we're going to make the container from the image we just created. This command has a little bit more to it, and put some notes here. So I'm going to create the container, but I'm also going to run it after I create it. I'm going to call it dev environment cpp. I'm going to tell it when I start the container, I want the user to be that developer user that we created. And then I'm going to mount the volume that we're creating. If there is no volume, if this is the first time you've run this and you've never created the volume, it will create the volume for you. So you don't have to change anything either way. So here we're mounting that volume. We're telling it the source and the destination directories. And then I am telling it, I believe this is the image that we're basing the container on. So that's the image name from up here. And then I'm telling it that when we start it, we want to start it using bash. So let's see if that works. And copy paste, plop that into the terminal. And what do you know, just like that, that command finished. And then we'll go to the Docker for Desktop UI and verify that these things were made. So here's the image. It says it's in use, which is a good sign. And it's in use because we just created this image, and you can see that this was last started 16 seconds ago. And over here, you'll notice this prompt is not my Windows prompt, but this is inside of the container that we just made. And sure enough, if I do an ls, I see my volume. So I'm going to cd into the volume, and I will cd into my get workspace. You won't have this. I've made this after I created that volume in previous containers. So once you get into the volume directory, you might have to make a directory for your get workspace or whatever you want to put in there. The next thing I think I want to show you is how to copy files from your host machine to the Docker container, or maybe from the Docker container to the host machine. If you're used to using a virtual machine, you might have designated some kind of shared folder and then copied files back and forth. Or maybe you've used the SCP protocol to do a file transfer. Docker has a copy command that we can use. So to demonstrate, I'm going to go into the dev environment CPP project that we pulled via Git onto the host machine. And I want to get this README file into the Docker container. So I'm going to start a terminal here, and I'm going to say Docker CP, the file name, and then I'm going to name the container that I want to copy to, and then the path in the container that I'm copying the file to. Now, don't use a relative directory here. You're going to have to do the whole thing. So home developer, and we'll try that. And it says it was successful. We'll go back over here. And sure enough, there's the README file. And if you want to go the other direction, just flip these around. I didn't memorize all these commands. you can at any time go and look at the Docker docs, which are on their site, and they've got reference there for you. And here's the Docker container CP command with all explanation of all the arguments. You can also look up the other commands that we ran if you want to look up Docker build or Docker run, and even dig into some of the ones here that we didn't touch on. All right, so I've got my Docker container. Supposedly all the software I need is installed. I think the only thing left is to actually do a C++ project and see if it works. So we can see my Docker container here. It's currently not running. I have since got a new computer since I started making this video, so I don't expect my volume will actually have anything in it. And I'm having a little trouble even remembering, how do I get into Docker and attach to it? Well, lucky for me, took some notes, and it's right here in my Dockerfile. Here's the command to start the Docker container and attach to it. I'll bring up my command window that starts it up, and I can issue my commands there. You can also get in via the Docker for desktop GUI right here. Problem with this is I don't have my tab complete. I don't have my home and end keys, and I just can't live that way. So I'm not going to do that. I'm going to use my command window here where everything is functioning. So let's see, CD volume, my tab complete works, my home, my end key works. I've got a get workspace folder, and indeed it's empty. This would be a good time to mention that because you're using a container, you may or may not already have your SSH keys for your Git repository set up. And if you're, giving a Docker file to someone else and they're going to go create a container and develop on it, you don't want to share your keys. Everybody needs their own individual keys. So don't put the keys into the Docker file and have them pre-generated. Give the container to somebody and have them go set up their own keys. The instructions for setting up your Git repository keys should be in that Git repository's documentation. For instance, if I'm using GitHub, here's the instructions right here. I can just plug that into Google, generate SSH key GitHub, and it tells you how you're going to make the key and how you add it to your settings. So for GitHub in Linux, you've got the SSH key gen. I'm not going to show you because I don't want you to see my keys, obviously. But you'd plug this command in, replace your email address, very standard stuff. If you develop for a while, you've probably done this a million times. Go and eval it, add it, etc. And then you would go up to, here's a repo that I have marked as private, so you probably can't see it. You go up here, go to settings, and in there's an item for add your SSH key. Add it there. The only other bit of configuration or setup that you might need to do is, since we're using Conan and you've got a fresh container set up, you're going to need to tell Conan, what operating system are you using, what's your preferred C++ version, all that kind of jazz. What ABI do you expect for all your dependencies, so that when it goes and looks for dependencies, it knows what your build environment looks like. So the command for that is Conan profile detect. And all of this, I'll probably go over again in a separate video covering Conan more in depth. This is mainly to focus on building the dev container in Docker. I don't want to get too heavy into Conan. I've already run this once off video because I wanted to make sure that everything compiled. So I've already got a Conan profile set up. Now that we've got our SSH keys set up for Git and we've got Conan configured, let's actually build something and make sure that our development environment is working. I've made a really simple HelloWorld repository on my GitHub. You can get the address up here. And all this is going to do is make a real simple application out of a library. And then I've got some unit tests that are using GTest, and GTest is going to be the dependency that I'm pulling to make sure that Conan works. And you can see the Conan file right here. I've got the one dependency, GTest, right there. And this is laid out such that I've got an application and a lib folder with the source, and then my includes for the library are here. And I just did some basic, made an interface and then made a base class, and then I made a concrete class right there. And the unit test is just going to test that my concrete class does what it says it does on one of its methods. So real simple project, should be easy to follow for most C++ beginners. We'll go over here, we'll get the address to clone it, and then I'm going to go into my container. Let me see if I had already pulled it. I did not. So I'm just going to do get clone, put in the address, and it pulls it down, and then I will cd in. The instructions to build it should be in the README. So I've got here is the command to tell Conan to go get the dependencies. And this is, again, only going to work if you have your profile set up. So make sure you set up your profile. So we'll do Conan install, tell it what folder, tell it that we're using C++20 and that we want debug. Looks like it finished successfully. It went and pulled my dependency. So then the next step is I'm going to cd into that build folder that it just made. And then this step is telling CMake to generate all the files and the toolchain file that Conan, use the toolchain file that Conan made. There we go. We generated everything. You can see we've got our targets here for GTest and gmock. So those dependencies are working. Compiler version, C++20. Everything looks good. If you've used CMake before, this should all be very familiar. And here I'm going to issue the actual build command to build the source. Pretty simple project, built really quick. I've got my library, I've got my application that uses the library, and then I've got my unit tests. And remember, because we're using Conan, not only can you use that for third-party dependencies, but you could use it for your own dependencies. I could very well have this library in a separate repo, make a dependency out of it with Conan, check it into some kind of repository for my binaries, my artifacts. Artifactory is one that I've used before. And then we could use Conan to pull that lib rather than having this lib in the repo here. And you could do that with all manner of libraries. Let's see if I remember right. I made some unit tests, and it should be in the test directory. And then, what was it called? It's called hello test. We will execute those unit tests. And we see that it ran fine. So we've built everything. We got our dependencies okay, and the unit tests run without a hitch. And our instructions appear to be satisfactory. The last thing I want to show you is how to work with an IDE in the Docker container. It depends on which IDE you prefer using. They all have different ways of configuring this. I'm going to use VSCode as an example because it's free and everyone will be able to go and get it. So if you don't have VSCode installed, you can just plop that into Google and go download it and install it. Once you have it installed, because I've already attached to my container and worked with a project, it's going to open the last project I worked with. I'm going to close this out so that it looks like what you're going to see. So you just come up with a screen kind of like this, and you wouldn't have anything under recent. The first place to look once you have a fresh install is what extensions you have installed. I'm going to try to just do the bare minimum here, although themes is probably not even needed. I just like the dark screen. You're going to need dev containers. There is also a Docker extension, but I don't use the Docker extension. I use the dev containers extension. C++, C++ extension pack, and CMake tools. Once we have these extensions installed, what we can do is Control-Shift-P in VS Code, brings up the command palette, and there's going to be one called dev containers attached to running container. If you don't see it there, you can just type in dev containers and it'll bring all the commands that start with that. So I'm going to click on that. And as you can see, it sees our container that we made, the dev environment CPP. I'm going to click on that. And then because I've already had this project open before, it opens up the project. I'm going to close this folder. Now this is in the container. So I can go to open folder and then you can see this is the path in the container that it's currently looking at. So I'm going to do home developer volume get workspace. And then I've pulled that HelloWorld CPP project into that get workspace. I'm going to hit OK. Because this project had CMake files in it, the CMake extension in VS Code detected that and it parsed the CMake. And you can see that everything was parsed and generated down here. You should have some output. In VS Code, there's a couple things that could go wrong and some tricks to go get around those things that could go wrong. If you need to, say, start over from scratch, something's wrong with configuration and you want to do everything that you can to have a clean start, you can just delete this build directory, go issue the command to Conan again to get the dependencies because Conan put a toolchain file here and it created this build directory for you. So when you delete that, reissue the command for Conan, and you can go down to your main CMake file and you can always do a clean reconfigure all projects. And as you can see, it went and generated all the CMake files again. And we have targets, we have dependencies, so we're good. There's also, in this project, CMake presets file. You're going to need the presets so that it knows what you're building and how you're building it. I didn't put much in here. I just did a quick configuration just to do a debug build. I don't think my user presets even has anything in it. The other thing that you need to be aware of is CMake has targets, right? So I've got the library, I've got the application, and I've got the unit tests. So I can change between targets. I can do that in the command palette, and I can just do CMake set. And here I can set the build target or I could set the debug target. Let's set the debug target. And right now it's set to the application. Let's set that to the test. And let's see what happens when I debug. So when I debugged, it went ahead and ran the test and it put the output from the test here. Now, if I change that, let's go back, command palette, CMake set debug target, hello world app. Now let's debug. All right, so it stopped because I put a breakpoint in the main function here and I'm actually debugging. And you can see it's executed this first line, but it did not execute the next line. So I can just do step over, which in VS Code is F10, and goes through the next line. And now you can see that the cow indeed says moo, just like speak and spell when we were little. And I'll hit F5 for continue. Sorry, I have to hover because I've been using CLion. Switching back and forth, you forget which is which. So I'll hit F5 and I continue. I think that's all that's to it. There is different ways to select the target. You can make a launch file and do all kinds of configuration in VS Code, but I don't want to get into that. I think this video is probably long enough, and I wanted the focus to be on running the Docker container and using that as a development environment. So I hope this helps, and take it easy.